Greetings humans, Mr. Lemon here. Rational numbers is what we're going to be talking about today. We have experience with other types of numbers like the natural numbers. There are counting numbers, 1, 2, 3, and so on. Then we experience whole numbers, like here's a whole, looks like 0. And then we have the numbers 1, 2, 3, 4. Those are our whole numbers. Integers include negative numbers as well. So negative 1, positive 1, positive 1. Positive 2, and so on. Rational numbers is what we're going to be focusing on today, and the rational numbers are a number that can be written as a fraction, so a over b. So like 22 over 7 is a rational number, 1/4 is a rational number, improper or proper fractions, here's a proper fraction, is also a rational number, and even stuff like this, 8 over 2, which is 4, but still falls in the category of a rational number, because it can be written as a fraction. Sweet. Okay, so you can either have a terminating fraction or a repeating fraction. And when I say fraction, I mean decimal. So when you have a terminating decimal, that's something like 3 over 4, which simplifies to 0.75. When you have a repeating decimal, of course, it's something that never ends. So something like 1/3, which is roughly equivalent to 0.33 forever. So we'll put a line over it to signify that it's a repeating fraction. And by fraction, I mean decimal. So I'm going to kind of take it for granted that you guys know how to change a fraction, like 3/8, into a decimal. You make this guy fall over, and you divide. So you've got 8 dividing 3, but 3 is really 3.0. And you ask yourself, how many times does 8 go into 3? That's 0. If you're dividing decimals, you just bring straight up that decimal point right there. And you ask yourself, how many times does 8 go into 30? And I think the answer today would be 3. Left with 24. And you've got an infinite amount of zeros out here, so you can bring down another 0. Here's a 7 for 56. And again, I'm taking this for granted, that's why I'm going pretty quickly through this. And that ends with a 5. 8 times 5 is 40, and it looks like it's a terminating decimal because you don't have anything left over right here. And it's not the same thing repeating up here. Sometimes you'll find yourself alone in the woods and you run into something like this, though, where you've got 5 is being divided by 11. Well, 5 is really 5.000 forever, and you're looking for something that goes into 5, but 11 can't, so you put a 0 there, bring up that decimal, and you ask yourself how many 11s can go into 50, and it's 4. When you do that, you're going to be left over with a 6, D, and you look and see, well, I guess it's 5 that goes in, and we've got 55, and you're back to where there's a 50. And you're like, well, I've done this before, let me put a 4 here. And when you do this, and oh my goodness, you're left with a 6, D, and you're like, wait a second, I've been here before, so you put a 5. And you'll notice that you keep doing the same thing over. It's almost like you're repeating the same thing over and over again. So in order to signify that, you can just say 0.45 repeating, or you can actually draw the line over all of this and say that 0.45 is repeating forever and ever. But you know all that mess. Let's move on to how we can write terminating decimals as fractions. So here we go. If you have the number 0.7, that's the same as 7/10. Well, I guess it's as simple as knowing these place values. The numbers that are to the right of the decimal are tenths place, our hundredths place, thousandths, 10,000ths, 100,000ths, and so on. So as long as you can read these numbers, 423, but it's 0.423, which means 1, 2, 3, so this is the thousandths place. So you have 423 thousandths. That's pretty simple. And maybe if you needed to, you can then simplify this fraction if it called for it. If you have a question with this, we can talk about it later. But we're moving on to how to write a repeating decimal as a fraction. This gets a bit tricky. So let's take a look at the first example we have here. And let's try to write 0.93 repeating as a fraction. Well, let's do this. Let's let x be equal to this number 0.93 repeating. And since there are two digits that are repeating, count them, 1, 2, we're going to multiply each side of this equation by 10 to the second, or 100. When we do that, we can find that 100x is equal to 93.93 repeating. If you multiply a number by 100, it's enough to move this decimal over twice to the right. So here we have 93.93. So what? Well, since x, as we discussed earlier, is equal to this idea, stay with me, because what we're going to do is subtract x from both sides. When you subtract x from this side, you get the result of 99x. And when you subtract x from this side, instead of using x, I'm going to use what x is equal to. And x is equal to this number right here. So I'm going to subtract that number, which is 0.93 repeating. Well, that seems to be the same as this part of it. So these will go away. And you're left with 93. Well, this looks easy to solve now, because all we need to do is divide 99 on each side, and it looks like x is worth 93 over 99, which can simplify to, if you divide the top by 3 and you divide the bottom by 3, there's your answer. Okay, we'll keep that one small and up there so you can reference it, but let's try another one. Let's try to turn 0.3 repeating into a fraction. Pause the video and see if you can take this process and apply it to this number 0.3 repeating. Here we go. Well, you've got exactly how many digits repeating? Well, it looks like 1. So let's multiply each side by 10. Each side of what? Well, let's call x equal to this 0.3 repeating idea, and then let's multiply each side by 10, just like we did here, multiplying by 100 in this example up here, because two digits were repeating. Here we're multiplied by 10 on each side. And when you do that, the decimal just moves over once. So you've got 3.3, but the 0.3 is the repeating idea. Now, we're going to do the same thing with subtracting x from both sides. When we do that, well, x is the same as 0.3 repeating. So on the the left side, you'll have 9x, and on the right side, you'll have just a 3 because we've got rid of this part. When you divide 9 on each side, you'll see what x is. And x is equal to 3 over 9, which simplifies to 1/3. Try to write this repeating decimal right there as a fraction. That's your homework. Show me tomorrow, and maybe I will go like this, or maybe I'll go like this, or maybe I'll go like this, but probably like this, because Toodles.